All right, so 7.7 goes over factoring special products. With these, the first thing that we're going to be doing is the difference of squares. So if we look at example 1, we are given x squared minus 25. When we're looking at the difference of squares, we can take the square root of the first term, we can take the square root of the second term, and there is a subtraction sign between the two terms. So when we are looking at this, we have an a and a b. Our a is the square root of that first term. If we take the square root of that x squared for our a, we just get x. For the b, if we take the square root of the 25, we get 5. So with this, we're going to use the formula for the difference of squares, which is just a plus b times a minus b. We plug these values in. We have x plus 5 times x minus 5. From here, we have our answer. For example B, we are given 4z squared minus 1. So again, I have a binomial. The two terms are separated by subtraction. I can take the square root of the 4z squared. I can take the square root of that 1. So my a is going to be the square root of 4z squared, which is 2z. I can take the square root of that 1, which is just 1. So again, I'm going to use the difference of squares formula. So a plus b times a minus b. I plug in my values. This is going to give us 2z plus 1 times 2z minus 1. For example C, we are given x squared minus 36. So again, I have a binomial, I have subtraction there. I can take the square root of both of those terms. So our a is going to be the square root of x squared, which is x. Our b is the square root of 36, which is 6. We are going to use the difference of squares formula. So a plus b times a minus b. This gives us x plus 6 times x minus 6. For example D, we have 100 minus m squared. So for this one, again, I can take the square root of that 100. I can take the square root of that m squared. My a is going to be the square root of 100, which is 10. Our b is going to be the square root of m squared, which is m. So again, difference of squares here. A plus b times a minus b gives us 10 plus m times 10 minus m. If we look at example E, we're given 9n squared minus 16. So we're going to take the square root of that 9n squared to get our a, which is 3n. Take the square root of the 16, which is our b, so that's 4. And use the difference of squares formula, so a plus b times a minus b. So this leaves us with 3n plus 4 times 3n minus 4. For example F, we have 16h squared minus 49. So again, we'll take the square root of the 16h squared. It gives us a of 4h. And we'll take the square root of the 49, which gives us b of 7. Use the difference of squares formula, so a plus b times a minus b. And it gives you 4h plus 7 times 4h minus 7. In example 2, we're evaluating numerical expressions using the pattern of a difference of squares. If we look at example A, we are given 54 squared minus 48 squared. Now, if you look at these, you could take the square root of both of these, and the sign in between them is subtraction. So our A is going to be the square root of 54 squared, which just is 54. Our B is the square root of 48 squared, which is just 48. Again, if we use the difference of squares formula, so A plus B times A minus B, we can solve this a little simpler. So this is going to give us 54 plus 48 times 54 minus 48. That 54 plus 48 gives us 102. That 54 minus 48 gives us 6. So if we just multiply these two, that 102 times 6, the 6 times 2 is 12, 6 times 0 is 0, plus 1 is 1, and 6 times 1 is 6. So that's 612 for our answer with this. For example, B, we're given 36 squared minus 34 squared. So again, we can take the square root of that 36, we can take the square root of the 34, there's subtraction between them. So we're going to do 36 plus 34 times 36 minus 34. The 36 plus 34 is 70. 36 minus 34 is 2. So 70 times 2 gives us 140. For example, C, we're given 47 squared minus 44 squared. So we can take the square root of the 47 squared. We can take the square root of that 44 squared. We have an A of 47, a B of 44. So we're going to use the A plus B times A minus B. This gives us 47 plus 44 times 47 minus 44. That 47 plus 44 gives us 91. 47 minus 44 is 3. The 3 times 1 is 3. The 3 times 9 is 27, so that's 273. In example D, we're given 55 squared minus 50 squared. So again, take the square root of the 55, take the square root of the 55 squared, take the square root of the 50 squared. We have an A of 55, a B of 50. So this is giving us 55 plus 50 times 55 minus 50. So from here, we're going to have 105 times 5. The 5 times 5 is 25. 5 times 0 plus 2 is 2. 5 times 1 is 5, so that's 525. For example, E, we have 28 squared minus 24 squared. So again, take the square root of the 28. It gives us an A of 28. Let's take the square root of the 24 squared. It gives us a B of 24. Use 28 plus 24 times 28 minus 24. The 28 plus 24 gives us 52. The 28 minus 24 gives us 4. 4 times 2 is 8. 4 times 5 is 20, so that's 208. The next part in this lesson that we are going to be going over is factoring perfect square trinomials. When you have these, there's two different ways of these happening. So it's either A plus B squared or A minus B squared. If you can take the square root of the first term, you can take the square root of the last term. And when you do that, you multiply it by either a -2 or a +2. It should give you that middle term. If it does, you have one of these scenarios. So if we look at example 3a, we have n squared plus 8n plus 16. We can take the square root of that n squared. It gives us n. We can take the square root of that 16. It gives us 4. If we multiply the n and the 4 by a +2, it gives us 8n, which is the same term as that middle term. Now, the way I know whether or not that 2 is positive or negative is because I take the sign on that middle term, which is why I circled that plus sign. From here, you have a perfect square trinomial. So you are going to use a plus b all raised to the second power in order to factor this. You said your a was the square root of the n squared. The b is the square root of the 16. Our sign between our a and our b raised to the second power is positive because our middle term is positive. So we plug in our values. This just gives us n plus 4 raised to the second power. For b, we're given 4x squared minus 12x plus 9. We can take the square root of that 4x squared. We can take the square root of that 9. The square root of that 4x squared gives us an a of 2x. The square root of the 9 gives us a b of 3. Now, the sign on our middle term here is negative, so if we take negative 2, we're going to have that negative 2 times 2x times 3, which gives us negative 12x. This negative 12x is the same as that middle term, so we do have a difference of squares here. So we are going to use a minus b, because our middle term is negative, raised to the second power. So this just gives us 2x minus 3 raised to the second power. For example C, we're given m squared minus 2m plus 1. So if I take the square root of the m squared, if I take the square root of that 1, my a is m, my b is 1. The sign on that middle term is negative, so I'm going to do a negative 2 times m times 1. I get negative 2m. That's my middle term. So I have a difference, or I have the perfect square trinomial here. So I'm going to use a, my middle term was negative, minus b squared. I plug in my values. A is m, b is 1, so that's m minus 1 to the second power. In example D, we have, C, we have d squared minus 10d plus 25. So again, I can take the square root of that d squared, it gives us d. I can take the square root of that 25, it gives us 5. The sign on our middle term is negative, so if I do a negative 2 times d times 5, we get negative 10d, which is the same term as that middle term. So that middle term was negative, we can use a minus b to the second power. This gives us d minus 5 squared. In our next example, we have 9x squared plus 36x plus 36. We can take the square root of that 9x squared, it gives us 3x. We can take the square root of the 36, it gives us 6. From here, if I take a positive 2, since my middle term is positive, and I multiply it by 3x and 6, we get 36x. That 36x is the same exact term as that middle term here. So we are going to use a, my middle term is positive, plus b squared. From here, we're just going to have 3x plus 6 raised to the second power. From everything that we've done so far, we can use what we know to solve these polynomial equations. You want to remember a couple things with these. First, make sure that your equation is set equal to 0. If it's not set equal to 0, get everything on the same side. Second, make sure it's in standard form. Lastly, if you can factor out a greatest common factor, start by factoring out a greatest common factor. If we look at example 4a, we are given x squared plus 2/3 x plus 1/9 is equal to 0. We have a perfect square trinomial here because we can take the square root of x, it gives us x. We can take the square root of 1/9, it gives us 1/3. If we take a positive 2 and we multiply it by x and 1/3, it gives us 2/3 x. From here, we can use a plus b, since our middle term is positive, squared. And this just leaves us with x plus 1/3 raised to the second power. Now with this is equal to 0. So don't forget, like I just did, to keep it equal to 0 and solve. For this, if we can start this by taking the square root of each side, we can take the square root of each side. It gets rid of that power. So we just have x plus 1/3 is equal to 0. We subtract the 1/3 from each side, and we get that x is equal to negative 1/3. For example B, we have a squared plus 6a plus 9 is equal to 0. Again, we can take the square root of the a, it's a. The a squared, it's a. We can take the square root of the 9, it's 3. 2, because it's positive 6a times 3 is 6a. So this factors out to be a plus 3 squared is equal to 0. We're going to take the square root of each side here. So this just cancels out our power, and we have a plus 3 is equal to 0. We subtract the 3 over, and we get a is equal to negative 3. Just like with any other equation that you're solving for, you can take your answer and plug it back into the original problem and see if you get a true statement. If you do, you know your answer is correct. If we look at example C, we have w squared minus 7/3 w plus 49 over 36 is equal to 0. If we take the square root of that w squared, we get w. If we take the square root of that 49 over 36, we get 7 over 6. That sign in the middle term is negative, so if we do negative 2 times w times 7 over 6, this gives us negative 14 over 6w, which is negative 7 over 3w. That is the same exact term as that middle term, so we are going to use that a minus b squared is equal to 0. From here, we plug in these values. We have w minus 7 over 6 raised to the second power is equal to 0. Take the square root of both sides. It cancels out the power. You have w minus 7/6 is equal to 0. Add the 7/6 to each side, and you get that w is equal to 7 over 6. For example D, we have n squared minus 81 is equal to 0. So this one, we have a difference of 2 squares. The reason why we know that is because the 2 are separated by subtraction, and we can take the square root of the n squared, which gives us n, and we can take the square root of the 81, which gives us 9. So remember, difference of squares, we're going to have a plus b times a minus b is equal to 0. So we plug in our a, which is n, and our b, which is 9. This is going to give us n plus 9 times n minus 9 is equal to 0. From here, n plus 9 is equal to 0, n minus 9 is equal to 0. So we just set each part equal to 0. We're going to move the 9 over. We get that n is equal to negative 9. We move this 9 over. We get that n is equal to positive 9. So you have 2 solutions for this one that's negative 9, one that's positive 9. Now, there is another way of doing this problem as well. So we started this n squared minus 81 is equal to 0. You could have also taken this and gotten n squared by itself, since it's just a binomial and that other term within the binomial doesn't have a variable attached to it. So by doing this, we could add the 81 to each side. This isolates the n squared, as n squared is equal to 81. From here, we want n, not n squared, so we would have to take the square root of both sides. It cancels out the power on the n to just give us n. And we have the square root of 81. Now, when you take the square root of each side of an equation, you have to include the positive and the negative in order to represent what that number could be. Because if you take negative 9 and you square it, you're going to get a positive 81. If you take a positive 9 and you square it, you're going to get a positive 81. So you need both types of answers. So you can have plus or minus 9 for your answer as well. So just another way of doing it.